Welcome back for the online class. In previous class, we were discussed on correlation and convolution. The importance of correlation and convolution is mainly used for image filtering. That is, the filtering means we make the image smooth. Smooth in the sense the clarity of the image has been improved. Then how do we improve the clarity? By making use of the filtering techniques. Okay. In previous class, we were discussed on the technique for the image. Similarly, the very important operation, okay, that is a correlation and convolution, we have used a window, that is a template. The size of the template, okay, I shown with a 3 by 3, it may be 1 by 1, 5 by 5, 9 by 9, 15 by 15, odd numbers has to be taken because we need to find with center pixel. Okay. If I find with a 2 by 2, it is very difficult to find a center pixel because whenever you keep the W, that is an image, okay, the kernel on an image, the modified data has to be reflected onto the center pixel. It is a good practice to have an odd numbered matrix. Okay. This is what the image, I hope you can see the clarity of the image has been shown. I shown with like a 6 images. All the 6 images has been undergone with like a image smoothing by using a filter. Okay. The first one has used with okay, let us before this one, let us assume that the size of the image will be m by n. Okay, means it has got like a m rows and n columns. There's a m by n pixel size. The very first one has been used with a 3. What is the 3 here? It is a window. There is a kernel size. This will be like a 5. This will be 9, 15, 3, 5, 9, 15, 25 and 35. You can go up to like 45, 55 like this. Okay. Now you can observe the smoothness of the image. The smoothness of the image, okay, you will find better in 3, 5. Okay. Why? Because when we are operated with like a, let us check that it is a m will be 500 by 500 by 500 pixels. When we keep initially for the 3 pixels, there is a leftmost 3 by 3 pixels of an image, okay, and the window size will be W. When you keep here, okay, there is a 1 center pixel will be getting modified. Similarly, if I shift it, okay, shift it by 1 row and 1 column, again the center pixel will be getting modified. Means there is like 1 row shifting, 1 column shifting will be operated and the modified answer will be reflected for the center pixel. If I took for the 5 by 5, look at this one. So if it will be like okay, 5 by 5 image, okay, this if it is a 5 by 5 image, okay, 5 rows and 5 columns like this, 5 columns. Okay, look at this one. Okay, now this will be my center pixel. So how many values will be there? There is a total surrounded by, okay, 5 by 5. Okay, there is a 25 pixels are improving the center pixel. And if you shift it here, if you shift it by the next bit here, again it will go by this way. Means there is a more number of pixels are getting inward operated, so that the clarity since for the 5 by 5, okay, there is a little bit clarity has been improved from 3 by 3 to 5 by 5. But if we proceed for the like a further, there is like a windows for the kernels of 9 by 9, 15 by 15. I hope you can see the image will be getting blurred. The image may not be like clear. Okay, so the smoothness will be gone out. Means it will be the smoothness in the image is not retained. Since it is a good practice to have 3 by 3 and 5 by 5 a window size. Okay. Now it will be good. You will find a much better operation. Okay, for 3 by 3. Okay, now still if you want to improve, okay, there's a more smoothing has to be given. It is a good thing that you can use it with as one. There is a 1 by 1 pixel, but the process of operation will be lengthy. It means it will take a more number of steps. For 3 by 3, if it is like a lesser steps than 1, 5 by 5, it will take much lesser steps for the processing on an image. Okay, with respect to like your hardware, the time constraint will be a more for the 1 by 1. Okay, little bit it will be decreased for the 3 by 3, but 5 by 5 it would be little but decreases. But how you go, the time requirement for the hardware will be decreases, but you need to be compromised for the smoothness of the image. Okay, this is what how the operation need to be performed. Okay, the next one will be like a image sharpening. Okay. The sharpening is a technique on an image. The main objective of a sharpening is to highlight a transition in intensity. Okay. The transitions in the intensity. Okay. That is, the use of sharpening changes and include applications ranging from electronic printing and medical imaging. That's what the main objective of a image sharpening is to highlight the transitions are happening from pixel to pixel. Okay, let us take that if the pixel size is of 5 by 5. The image size is 5 by 5. If I took any one pixel out of that, if you are finding what will be the value of the next neighboring intensity value, then how much then when the neighboring pixel went from the current pixel to the neighboring pixel, how much the light intensity will be changing? That need to be measured. If you obtain the change in intensity from pixel to pixel, it is good practice to have for further operation on an image. Or also you need to get a mathematical equated image onto which you can perform n number of applications. Okay. Now before we proceed with like a sharpening, the sharpening involves with the basic operations with the first derivative and the second derivative. Means how good you want to make your image to be much sharpened. That is, you may go for like a first derivative or you may go for the second derivative. In the first derivative, okay, I'll just dictate with here. There is a 1 number, 2 and 3. In the first one, must be 0 in areas of constant intensity. The meaning of this, if there are all the pixels, means for all the pixels in the sense, if I consider in a one row, if all the pixels having a same intensity, means the area will be considered with a 0. Means there is no change in intensity. Okay, let us say that how it will be considered. If I consider there is a 1, 1, 1, 1, okay, these are all pixels. There is one pixel, second pixel, third pixel, fourth pixel. all the 4 pixels have a same intensity, means constant, that will be 0. Second one, must be non-zero at the onset of an intensity step or a ramp. Okay, either meaning that if there is a change from pixel to pixel, the value, okay, either it will be like a step or it will be ramp. Okay, how we will find a step and the ramp, we will come to with the equation and we will discuss on this more detail. Okay, for the third step, must be non-zero along ramps. I hope you understood. Okay, what is a ramp here? The ramp will be like a positive ramp or it will be negative ramp. We call it as a ramp. If it is in this way, means it is a positive ramp. If it is a down way, it is a negative ramp. Means if I take it in the positive ramp, means the intensity from pixel to pixel is increasing. If I take it the negative ramp, the intensity from pixel to pixel will be decreasing. I hope the point will be clear. Okay. That will be considered either ramp or a step. Okay, if for this one, okay, all the pixels will be same, what do you get here? Step. Okay, initially consider it's a 0, from 0 to 1 you will get a step. Okay. Similarly, any definition of a second derivative. Okay, now there are the like how good you want the image sharpening. More the derivative you go, more the complexity for the operation on an image. Since it has been given here with only 2 derivatives, there is the first derivative and the second derivative. In the first derivative, I made the 3 points very much clear for you. In the second derivative, it is the same here. There must be 0 in constant areas. The pixels having the same intensity are having 0. Second one, must be non-zero at the onset and end of an intensity step or a ramp. I will come to this point with an example so that in detail you can understand this operation of all the steps. Must be 0 along ramps of a constant slope. Okay, if there is a slope, okay, if it is a constant in the sense onset means if there is a transition from positive to negative, negative to positive, then you might be getting a non-zero. If it is like a constant ramp, means you will get a 0. Okay, we will see how we get a 0 or a non-zero in detail. Okay, now here by using this one, I given with two equations, one with like a first derivative, okay, second with the second derivative. Okay, I hope you can see here. Okay, the first derivative, dou of x divided by dou x is equal to f of x plus 1 minus f of x. Okay, f of x. Okay, now I said the image will be represented with f. Okay, if it is f of x means the current pixel. F of x plus 1 means the next pixel. I hope you understood. Okay, let us assume that I have a pixel here, one pixel, second pixel and third pixel, like this. If this is f of x means the current pixel. What is this? F of, sorry for this one, f of x plus 1. Okay, now this is f of x. Okay, f of x plus 1. What could be the next one here? F of x minus 1. Okay, I hope you are very good knowledge on this f of x and f of x plus 1, f of x minus 1. Okay, I am using currently with the 3 because f of x plus 1, f of x minus 1. Okay, is the thing clear here? I hope. Now this is the first derivative. Now similarly, second derivative, obviously the second derivative will be dou square f divided by dou x square. In this, the equation will be f of x plus 1 plus f of x minus 1 minus 2f of x. Okay. By using this one, we'll see with one simple example based on which you can understand how the step and the ramp has been obtained. Okay. Now, we'll go with this one. I hope it is very much clear for you. Okay. I'll come to this point. Now, there is in this example, there is like a 6 intensity levels are given. Means there is a intensity level for the image has been given with only 6. Okay, means my image is now represented with the 6 levels. What are those? 0, 1, 2, 3, 4, 5 and 6. Okay, means if you can have the image of a representation 6, okay, 32, 64, 128 depends. Okay, now for to understand I given with the intensity of a 6. Let us assume that for an image, okay, there is a like a image 1 pixel I consider. This pixel has a value of a 6, intensity value of 6. There is a one more pixel, there is a neighbor pixel has an intensity of a 6. Third pixel, what is the intensity? 6. Fourth pixel is also having an intensity of 6. Means there are like a 4 pixels. 4 pixels are having an intensity of a 6. Okay. Then suddenly when you go for the like a next pixel, I just there is like a depends on like a image. I got here next pixel, its value is a 5. Intensity is changed here now. Now what was the previous pixel value? The previous pixel value intensity is 6. Now what the current pixel intensity is 5. Right? Okay. And there is one more pixel, its intensity is 4. This is 3, 2. Okay, and this will be like a 1. Okay, the intensity values of this all this pixel. Okay, look at this. Can I say in the first derivative I said all the pixels having a same intensity must be having 0. That is with the first derivative also and the second derivative. I'll come to this conclusion and I'll show with the answer for you. Okay, now this is what we call is an onset. Onset in the sense there is a change from pixel to pixel. When there is a change from pixel to pixel, there is an intensity changing, means either it will be going a positive ramp or it will be going a negative ramp. If it is a high, if it is increasing intensity, it is a positive ramp. If it is a decreasing intensity, it is a negative ramp. Depends on the value of the pixel. Okay, I hope these pixels will be clear for you. Okay, this will be 6, 6, 6 like this. Okay, now what is the intensity of this pixel? Is 1, 1, 1, 1, 1. You look into the x-axis of the graph. Okay, along the y-axis. Along the y-axis you can look the intensity. Sorry for that. Along the y-axis you can make it as a intensity levels. Along the x-axis is a time. We need not worry about this one at this moment. Okay, what is the intensity for the pixel? Is a 1. What is the intensity of this pixel now? 6. This one 6, 6, 6, and this is 6. Okay, this is what the whatever the graph you can, this graph it is visualized. It is drawn based on like a few pixels of an image. Few pixels. I consider with a few pixels onto which we have drawn, and we will perform a first derivative and a second derivative by using the operation of previous equation. Okay. Now, what is the first derivative? Okay, that is dou f divided by dou x is equal to f of x plus 1 minus f of x. Okay, I hope you can get it, this one. That is the previously drawn equation. Okay, now here also shown f of x plus 1 minus f of x. Okay, now I'll come to this one. Now each pixel, okay, will be measured and we will find its values. Okay, now the same here, the first derivative, whatever this one, the scan line, what we call scan line. What is the value of for the at this point? There is a high. What is the value of this one? 6. Okay. What is the value of this one here? Okay. Value of this one will be 6. 6. Okay. The same thing has been written here. 6. What is the value? 5, 4, 3, 2, and 1. These all will be 1, 1. Okay, 1, 1. Now what is the value? 6, 6, 6, 6. Okay. This is a scan line what we obtained the values from the pixels. Okay. Okay. Now let us take what the first derivative will be. Dou f of x, dou f divided by dou x is equal to f of x plus 1 minus f of x. Okay. Now let us consider with the first one. Okay. Now you consider the first point, this one. If I consider this will be like a f of x, okay, means the current pixel. I'm performing a first derivative here for to understand first derivative. This is f of x. What will be the f of x plus 1? It's a neighboring value, this value, that is f of x plus 1. Means what is the value of f of x? 6. F of x plus 1? 6. What is the equation of dou f divided by f? That is f of x plus 1 minus f of x. Okay. What is the value of f of x plus 1? 6. 6 minus 6 here, you will get a 6, 0. I hope you understood this one. Okay. Now, little bit, you go for this one. Okay. Now I'll come to the point of here. Now this is my current pixel because I'm performing a first derivative. Now this is f of x. Okay, this will be like f of x plus 1. Okay. Now what is the value of f of x? 6. 6 minus 6, you will get a 0. This is the first derivative answer. Okay. Now we'll go with the next one here too. Now okay. Now look at this. Okay. Now I'll come. I shown with this one. Now this will be what? F of x. What is the value of f of x? 6. F of x plus 1. Okay. Sorry. F of x here. Okay. 6. Okay. Now 6 minus 6, you will get a 0. Because this is f of x here. F of x plus 1 is 6. 6 minus 6 is a 0. What the answer you get here? Okay. Now I'll come to this one. Okay. Now I will come to this one. Okay. Now I make it with the f of x. Okay. F of x. This is my f of x. What is the f of x plus 1? 5. That is nothing but what you have to do here? 5 minus 6. What is the answer you get here? Minus 1. You get here minus 1. I hope you are getting it now. Okay. Now I'll come to the next point. Okay. I hope you understood this one, how I got a 1 here, minus 1. Now I'll come to this point. What is the value of f of x? 5. F of x plus 1. Okay, that is f of x plus 1. Okay, that is 4. 4 minus 5. Okay, that is minus 1. Okay, I'll for the simplicity I'll make it with all the operations in this way. Okay, once you subtract 4 minus 5 minus 1, 3 minus 4 minus 1, 2 minus 3 minus 1. Just okay, reverse way. 1 minus 2 minus 1, 1 minus 1 0. Okay, like this. Whatever I am performing here. Okay, 1 minus 2 minus 1. 1 minus 1 0, 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 1 minus, okay, that is 6 minus 1 5, 6, 6 minus 1, 5, 6 minus 6, 0, 6 minus 6, 0, 6 minus 6, 0, 6 minus 6, 0. There is no value, you end up here. I hope you are getting this one. In the first derivative, f of x plus 1, the next value, f of x is the current pixel value. Okay. Now, okay, this is what the first derivative values what you obtain. Okay. Now, I'll come to the point of the first derivative, how we'll get here. Okay. Now, when we obtain the first derivative of the answer, look at this. Now, this is the intensity, the change, the graph has been drawn. Okay. Now, the intensity will be changing either positive or it will be changing with the negative. Means it will be increasing positive, it will be decreasing, it will be negative. Okay. Now, I'll take here how many values are considered? The 6 intensities. Since we are drawn with plus 5, okay, there is a positive 5, minus 5, down by. Okay. Now, look at this one. When we draw the graph, okay, you just make it. What is the intensity you are getting here? Okay. Sorry for this one. Okay. What is the intensity you are getting here? 0, 0. Because a positive side and the negative side, what is the value? 0. Minus 1, you make it minus 1. Minus 1, here this is minus 1. You just put a point here, cross, minus 1. All the values you make it here. Okay. Now, look at this one. There is a transition is happening from 0 to 5. This is 0 and 5. Okay. Again 0, 0. I am just 0, 0 like this. If when you get here graph, okay. Now this you will connect the graph like this. Okay. Now the graph has been obtained. This is a graph of like a first derivative. I hope that clearly you can visualize, okay, in which this is a constant. This is what you are getting, a constant. Means there is a constant. What the statement I told here? Okay, if there is a ramp, a constant ramp, okay, the constant change is happening, the intensity will be constant. Means it will be 0. It will be 0, whatever the value. Okay. Whatever 0 here getting 0 answers. Now, similarly, we will go with the second derivative. What is the second derivative equation will be? Now, that is dou square f divided by, I will come to this one. Okay. Dou square f divided by dou x square is equal to f of x plus 1 plus f of x minus 1 minus 2 f of x. Okay. I hope you understood this one. Now, we'll perform the same operation how we are done with the previously. Now, this is the second derivative. Now, if I consider this will be my f of x, this will be f of x plus 1 and this will be, what is that? F of x minus 1. Current pixel, because the current pixel, this is f of x, the next pixel, okay, you need to go from the scanning line, f of x plus 1, my previous, there is a below one, f of x minus 1. Okay. By using this way, we will perform a second derivative operation. Okay. Let me go with the second derivative. I'll find with this one, because there is no, for the first pixel, there is no value can be correspondingly obtained. Now, I'll come to this one. Okay. Now, what is the f of x? What is the value of f of x here? 6. Okay. I'll write here f of x plus 1 minus f of x minus, f of x plus 1 minus 2 f of x. This is what the equation what you get here. Okay. Now, what is the value of f of x here? For this one, for the current pixel is minus 2 into 6. Right. because f of x. What is the value of f of x plus 1? 6. For this is a 6. F of x minus 1, it is again a 6. So you make a 6 plus 6 minus 12. There is a 12 minus 12, you will get a 0. Okay, I hope you are getting this one. This is what the 0 you obtained. Okay, is the concept clear for you? Okay, now when I go for like a next pixel, this pixel. Okay, now what is again we will go with the f of x plus 1 plus f of x minus 1 minus 2f of x. Okay, now what is the value of f of x here? That is minus 2 into 6 again. Okay, because I am going with the reverse way. Okay, for the operation. Now what is the f of x plus 1? It is a 6. Okay, now what is the value of 6 plus 6? What is the f of x minus 1? 6. Again you will find a 0. This is a 0 what you get here. Okay, I hope you understood this one. Okay, now I'll come to the this operation. Okay, now what is the value of f of x? Minus 2 into 6. F of x plus 1. F of x plus 1 is not the 6 now, here 5. Right. F of x minus 1 is a 6. So what will get here? Okay, that is 11 minus 12. You will find a minus 1. So this is the answer. What you get? Minus 1. Minus 1. I hope you are getting it now. Okay. Similarly, I'll go with one more here for to understand. Let us take with this current operation. What is the value of f of x? That is minus 2 into 5. F of x plus 1, 4. F of x minus 1, 6. That is 0. You will get a 0. Okay. Similarly, when you perform for all the image, okay, you will get here 0, 0, 0, 1, 0, 0, 0, 5, minus 5, 0, 0. Okay. Now, I hope you just go with the trick question here. Okay. You will end up with the answer. When you end up with the answer, same way what I had drawn with like a previously, okay, you take the values of these images, okay, that is 0, fine, 0, minus 1, okay. Now what you just I'm showing with like a green here, 0, 0, 0, this 0, okay. Now this is 0, 1, 0, 0, 0, 0, okay. Now there is again the transition you have obtained. Now what the transition here now? 5. It is next one here, minus 5. Minus 5. Next 0, 0, 0. Okay. When you connect this one, okay, whatever the pixel value you get here, this is what the a transition line you got for your second derivative. What will be the first derivative? Okay, the first derivative will be this one. The first derivative. I hope with a red colored line what I have drawn, it is the first derivative, the output transition for the given image pixel values. Similarly for the green, for the second derivative. This is what the operation will be performed, okay, the first order and the second order. We call it the first order also, second order also. First derivative, second derivative. Okay. Now, why we are performing this one? Okay. When you are performing this operation, okay, you will end up, okay, more the derivative you will get here, more the clarity, more the image will be sharpened, means more the highlighting, more the highlighting of an image to be obtained, and you will get a better applications, but the complexity will be increases. Okay. I hope you understood this image, the sharpening technique, how it is performed here. Okay. For the coming class, there are like a few the standard operations will be performed, okay, based on which it will be operated for the most of like a image applications. Okay, just look into this one, and the very much important for first order and the second order derivative will be, these are the equation f of x plus 1 minus f of x plus 1, f of x minus 1 minus 2 f of x, and the whatever the operation is there, and all the principal operation, the principal steps what I shown, what I given here. First derivative will be 1 2 3, the second derivative will be like 2 3, or 1 2 3, all are I have proved with respect to your image pixels, and you verify this one with whatever the graph I obtained. Okay, I hope you understood. You can go with further any application, and it will be performed in this way only. Okay, thank you.